I'm from Estonian Agricultural Registers and Information Board, which is called PRIA in Estonian, Põllumajanduse Registrite Informatsiooni Amet. I'm working as a project manager. And I agreed to do today a little overview or introduction about project NIVA, which we have currently ongoing. And I have to say that I am not a remote sensing expert, and my presentation, it will not be about remote sensing. NIVA project has some connections with this topic, and some countries are having more connection with this. But nevertheless, I hope the presentation, the project information, it will be at least useful to know. So, as I said, I will speak a little bit about the project in general, what it is about, which countries are participating. And in the last part of my presentation, I will say a few words about what we do in Estonia in this project. And before I start with the project, I will explain some terms, some acronyms which we use, and this information helps perhaps better to understand what it is about, because NIVA project is related to common agricultural policy, and this is something, all these terms are related to this topic. Common agricultural policy, it is a pan-European policy which applies to all European countries, and this is the instrument for supporting agriculture in different countries. Direct payments and different rural development measures are paid to farmers via this policy. This policy is changing over the time, and currently we are in the middle of this point of change. It will change every 7 years. And there is a term called CAP Post 2020, which means the future common agricultural policy and its concept. The main change from current state is that when currently it is concentrated on making the on-the-spot checks. We give farmers some money, and afterwards inspectors will go to the field and check on the spot if everything is correct. And the current, the future state is foreseen that this checking will be done on an ongoing basis, a continuous monitoring. We have different information systems. We have remote sensing data. And the common understanding is that this all should be used for continuous monitoring, which would be less burden for farmers as well, because they don't need to go to the fields and show everything, but this can be done on an ongoing basis. And if something uncompliance is noticed, then farmer can be notified and this corrected without sanctions. So that's the main idea. Paying agencies are the government bodies in each country who are paying this money actually to farmers. So in Estonia it is PRIA. Ajax, Integrated Administration and Control System, it is the information system used in every of these paying agencies for managing the payments. And the Ajax is a common term for this concept of such information system. Actually, every country has developed their own Ajax systems. They had the rules which how this system should look like. They have been given by the European Commission, but every country has developed their own system, so there are a little differences. The main components, however, are the same. Ajax has different subsystems which are meant for different which are having different functionalities. For example, LPIS, Land Parcel Identification System, it is actually a geographical information system inside Ajax, where every field or every agricultural parcel is recorded. There are also other subsystems like animal registry, where all animals are counted for, aid applications and payment claim systems, where farmers are making their claims for payments. Client registry, where client details or farmer details are recorded. Yes. Next one, the FMIS, or Farm Management Information System. This has particular meaning in relation with the Estonian use case I'm going to speak about a little more later. Farm management information systems, it is a common term for information systems which are used by farmers. If Ajax is mainly used by paying agency, then FMIS is something used by farmers. And they use it for recording agricultural data, different data like work performed on a particular field, data about fertilizers or plant protection products, things like that. And I'm going to speak why it is important in the context of paying agencies and Ajax a little later. And the last, the GESA, geospatial aid application. It is when farmers are making payment claims to the paying agency, it is done via geospatial aid application. So it's just a name for that. So about NIVA. NIVA is an acronym for New Ajax, Vision in Action. It is not a car. So Ajax is this information systems paying agencies use. And the new Ajax vision, it means that as the common agricultural policy is changing, also the Ajax, which is a software instrument to manage this implementation of this policy, it also has to change. So the project is funded by Horizon 2020. And as said, the main purpose is to develop digital solutions and different tools to modernize the implementation of CAP. Project started last June, and it will end in May 2022. And there are in total 27 partners in this project consortium, 9 paying agencies. Paying agencies are the governmental bodies who are implementing common agricultural policy in every country, and plus technical partners. And from Estonia, there are 2 members, Agricultural Registers and Information Board, and also University of Tartu, in particular Tartu Observatory, is also participating in the NIVA project. So here's a diagram about project goal. When I said that the main purpose is to change the Ajax, to modernize it, because as we are moving from one phase from the on-spot checks to this continuous monitoring, then we have to also change the Ajax, how it is built up, which data it uses, and what are the procedures. These have to be changed a little, and the ultimate purpose is to make it less complex and easier to use, both for paying agencies and also the results of this making it all less complex should be reduced administrative burden for farmers. So they need to less they need to less think about it, which data to present, because paying agencies are able to get this data directly from different databases or from remote sensing. The project is built up based on 9 use cases. And when I say use case, it is not in the usual meaning of use case as we may imagine in software engineering, which means a list of actions or steps defining the interactions between an actor and a system. The use case, they are meaning more of a pilot project, small pilot projects inside this big NIVA project. And each use case, it is trying to solve a particular problem or issue related to this Ajax system and Common Agricultural Policy post-2020. And they can be divided into groups according to the process, or it may be called process they are dealing with. So there are 4 groups: monitoring, self-certification, seamless claim. The claim is payment claim, which farmers are doing. And some use cases, they are grouped as other processes. There are not separate names for those. So the first group is monitoring group. Monitoring is means the paying agency's ability to continuously see what farmers are doing. Are they following all the rules, etc. So the first use case 1A, it is developed in Greece. Greek paying agency is leading it, and actually this is the use case which is related to remote sensing and Earth observation, because their goal is to develop a tool or some aid program for paying agencies for monitoring agricultural parcels and assigning traffic light codes at parcel level. Traffic light codes meaning, are they red? Are they having red status, yellow status, or green status? And remote sentinel data is used for monitoring the land cover, how it changes, and the crops, things like that. Red means that it is not according to how it should be. Green means that it is okay, and yellow means that there are dubious cases. Second one, use case 1B, which is developed in France, agro-environmental monitoring. It is quite closely linked to use case 1A. In France, they are developing a set of indicators which would show some information about farmers' performance, about parcels, and the data they need for calculating those indicators. It is foreseen that this data will come from use case 1A. So there's a quite close link between those two use cases. And the third one, use case 1C, farmer performance, which is developed in Estonia. It was initially grouped also into this monitoring group, but actually we are a bit different. We don't have a remote sensing or Earth observation component in our use case. Monitoring means that we are trying to establish exchange of data between Ajax and the FMIS type of systems to get additional information from farmer's field book and use this. So that's the monitoring meaning for our use case. And I will speak a little bit more about Estonia a bit later. Self-certification use cases. Self-certification is meaning the farmer's self-certification. First one, use case 4A, geotagged photos. It is being developed in Ireland, and they are developing actually a geotagged photo making mobile app for farmers. So, if there are any dubious cases, farmer could go up to his field and take a picture, send it to a paying agency, and to prove that something is as he says. They are not developing from scratch because geotagged photo applications or components for that. There are some previous projects which have already developed something, so they are reusing some of these components and adding some new features. Use case 4B, machine data in this geospatial aid application, which is developed in Netherlands. It is a bit linked with Estonian use case in the meaning that they also are trying to get some data from farm management information system, but it is a machine data, if a farming machine data. So they want to get farming machine GPS data, which is obtained via farm management information system. And this can also be used in Ajax and could be a valuable additional source for paying agency. A seamless claim. Claim is a farmer's claim for a direct payment or some other aid which paying agencies are paying. First one, use case 5A, land parcel identification system update and change detection. It is developed in Denmark, and they are trying to make process of detecting the changes more automatic, or it is mainly aiming the paying agencies. This is something which is important for paying agencies when they have all of those agricultural parcels in their GIS system, and when changes occur, it would be nice if system would automatically detect them, not to have this human component to make the updates. So it is their main aim. Use case 5B, scheme eligibility and payment eligibility, developed in Italy. This is it's a quite complex one actually, because they are having a lot of information sources, but the main purpose is to prepare like a pre-filled application, claim application for farmer. If paying agency has information about the farmer, his or her activities, things like that, they can prepare like a pre-filled application, and if farmer agrees with it, then it's just click and pay. So he says that it is okay, and I want to apply for this such kind of aid. And the last group, the other processes, they are different from each other and different a bit from other use cases. First one, use case 2, pre-filled application. It is a bit similar with use case 5b, which also offers help for farmer to pre-fill the application. When the use case 2, it is dealing with one particular component of this application. It is a parcel boundary delineation. So every year when a farmer submits application, he has to draw the lines of the parcel boundaries, and they are trying to make it also more automatic, so the farmers would have less work and less errors. And use case 3, farm registry, developed in Spain. Their aim is to have an additional part to this Ajax system, to create a registry where all farms or farmers and a lot of different information would be in one place. So if you look up there, you could see every important aspect related to a particular farm or to a particular farmer. It is a bit overlapping with client registry, because in client registry also we have some information about farmers, beneficiaries, like contact details and things like that. But their aim is to develop something bigger, something having more information in there, not only just contact details, but also some other data, like are they dairy farmers or growing crops or something like that. So. And so this was all about the short introduction about different use cases. NIVA project has a website, and there is a lot more information about each use case, about the project in general. So if anyone has interest, then please visit the website. Okay, use case 1C, farmer performance. As I said, we are in the monitoring group, but we are not using the remote sensing data, but we are trying to establish exchange of data between paying agencies information system Ajax and between farmers information system FMIS. And currently the situation is that farmer can export some data related to him and his parcels from the Ajax to FMIS. But it involves a lot of handwork. It's you have to generate files in certain format, and it is not automatic and not so smooth. And the data flow from FMIS to Ajax, it doesn't currently exist. You can also import some some parcel boundaries data, but not much more. And our aim is to first establish this exchange of data, at least for some of the data. Of course, it won't be exchanging all of Ajax data and all of MIS data, but part of it, and then use this data. From paying agency's point of view, we have a lot of data in Ajax about farmer and activities performed in agricultural parcels or fields, but there are some data gaps, and we don't have the complete picture. And if we could get this missing data about different activities from farm management information system, then we would have the picture completed or a better overview. And the main idea is that such data sharing should be voluntary, because we can't force farmers to share the data. It shall be based on voluntary authorization. And the aim is that we are trying to make this exchange of data useful also for a farmer. So if, for example, if they allow to send some MIS data to Ajax, then, for example, paying agency can calculate or check some compliance and give him feedback. For example, are you compliant with requirements or not? So they are also benefiting from this exchange. So what are the steps of how we are developing our use case? We started collecting actually this farmers' feedback about it all, because they are, of course, very, very important part of the whole plan. So we conducted web survey in November last year, where we described our plans, what we intend to do, asked their feedback, and also asked feedback about the Estonian paying agencies' information systems and the agricultural data in Estonia in general. So to get a better picture of what farmers feel, how they feel about it, is the situation good or bad. Then we have collected also feedback from paying agencies of different member states about current status of Ajax MIS data exchange, because we know how the situation is in Estonia, but we wanted to map also how it is in other countries. And the third important part of developing this system is an Estonian startup company, Jäger. We are using their MIS software as an example when developing our prototype. So we are having a collaboration with them, and our prototype of this data exchange solution will based on Jäger software. And in order the exchange of data to be standardized, because the idea is that whatever we developed, the prototype, it should be extendable to other countries also. So we start in Estonia, we develop it here, but the results, they should be usable in other member states also, with the modifications, of course, but at least some parts of it. This is why we are aiming to have this exchange of data based on intermediary standard. When you take Ajax data, you will give it out in a standardized way, and from the other side, you will take FMIS data, standardize it, and receive it in Ajax. And the standard which we decided to use is called EGROP. The problem is that there are, on one hand, there are a lot of standards for agricultural data, different standards. For machinery data, it is the easiest. It is ISO standard, which applies for all countries. But for other data, there are several ones. And no one is actually better than others. They all have their pluses and minuses. And why we choose this EGROP? Well, it is developed initially in Netherlands. So it is their initiative, but it is proposed now to be used in a wider scale. And as NIVA project, the Netherlands paying agency, they already said that they will use it in their use case, which is getting farm machine data. So we looked at it a bit, and we decided that we will also try to use this standard. So not to waste too much time on looking for any more suitable one. And the idea was not to propose our own standard, but try to use some existing one and see how it works. So it is a tasting or exploring, is it good or is it bad? What are the pluses and minuses? So we will take a limited data set from Ajax data and some data from FMIS, and map it against EGROP. So we will do a kind of, you could say it is like a dictionary. You will say that in Ajax there is this field of data, and this is equal to this field of data in EGROP standard, and the other way around. The next step is some development in usual or normal software development sense. It is REST API, or application programming interface component, which will enable this exchange of data. And the message, the actual content in this message, it will be based on EGROP standards. And additional aspect of our use case is that the first step is to go create this automatic or machine-to-machine bidirectional exchange of data. And the second step is to use this additional data in a meaningful way. And our purpose is to try out, to propose some indicators which would show farmer performance, as our use case is called farmer performance, and it should be all about measuring the impact of farmers' activities to nature, to environment, and yes, so we want to have some indicators which will use both Ajax data and some additional data from FMIS, so, and calculate something based on that. So if to say in a compact way, then the outcome will be a microservice which will convert a limited set of Ajax data and FMIS data into EGROP format, and will enable an automatic exchange of data. The prototype of this service, it will be quite specific to Estonia, obviously, but the intention is that it is partly reusable, like recommended standards and data structure. So all of the results developed in NIVA, all software components, all information, all documentation, it will be made available under free access license. So this is one of the requirements in this project, and the whole idea is that in every country something is developed, and even if it is not directly reusable all across the Europe, it can be reused with some modifications. So that's the main idea. Okay, and this was my last slide. So I'm open to questions.
Thank you. Everybody can write their questions in the public chat, and it's also possible to use a microphone and to ask the questions.
Well, I can see the question by Mait, but I'm afraid I'm not the right person to answer to that. Because I'm actually not so knowledgeable about this background information. If it is okay, I will send an answer to this question later. I will try to find someone from ARIB who is perhaps can answer this one. Well, there are some use cases which we are looking with more interest. One of them is actually this geotag for photo app one, which is not about remote sensing, but it is planned in Estonia and Agricultural Registers and Information Board to develop also this kind of option for farmers. This is one. Regarding remote sensing, well, ARIB currently has this program for detecting if the grass mowing automatically Saticas. So we have already a solution for detecting this moving events. But the next step is to also to detect crop types. So this is something it is probably developed in France to some degree, and yes, if it is reusable, then of course we will use in Estonia. Does it answer your question? Well, I don't have information about exact numbers, how many farmers are using these remote sensing products in Estonia. When we did this farmers survey, then it turned out that there are kind of two types of farmers in Estonia. The bigger part are not using so much of technical advantages. Even like when they have farming machines, they sometimes have GPS functionalities, but they don't use them. And there is a small portion, like maybe 5 or 10%, who are using those different functionalities. So I don't know about the rumors, but my wild guess would be like perhaps there are 5 to 10% of farmers in Estonia who are making good use of all of the different developments and are very knowledgeable, because it also depends a little about the size of the farm. If you are a small scale farmer, you perhaps don't need all of this stuff. But of course, if you have a lot of land, then you need to have some science behind it.